Okay, so aluminium is Al, and then oxygen is O2. Remember, okay, remember oxygen, you don't write it as O, you write it as O2. So this is a word equation, you're changing it to a chemical equation. Aluminium oxide is Al2O3. Now this you cannot get wrong. You get this wrong, everything is wrong. So why is it Al2O3? Because aluminium is 3 plus, oxygen oxide is 2 negative. Okay, then only you balance. Then only you balance. So you have a 2 oxygen here, 3 oxygen here, so you put a 2 here. 2 times 3 is 6, 2 times 3 is 6, 2 times 2 is 4. Okay, so that's number 1. When you burn aluminium, this is the equation. Okay, number 2, burning of hexane. So at this stage, you don't know what's hexane, but it's okay. They give you here. Hexane is C6H14. So it's already, I already told you that just now, when it burns an oxygen, it produces carbon dioxide and water. Okay, how you balance the equation? You always balance the element last. Who's the element? Oxygen. So you balance this last. You balance everyone else first. So there's 6 carbon dioxide. Okay, sorry, it's 14 hydrogen. My 1 disappeared. Okay, 14 hydrogen, 7 water. Okay, so then you count the oxygen. 6 times 2, 12. 12 plus 7 is 19. Okay, so you have 19 oxygen. So you cannot put 19 over here, you put 19 over 2. So what we do to make this equation look nice, we take the whole equation and times 2. So over here, there's no number, means it's 1. So 1 times 2 is 2. 19 over 2 times 2 is 19. 6 times 2 is 12. Okay, and 7 times 2 is 14. All right, so this is how you balance this kind of equation. Okay, so I think most of you understand already. Okay, now I'm going to go to number 3. So number 3 is a little bit tricky. Okay, so sometimes, right, they will give you things like this. They will tell you things where they say ethanol. They won't ask you to write the equation, but formula, but they will give you things like CH3CH2SH, and they will tell you it burns in oxygen to produce carbon dioxide. So you must know what is the product. So anything that burns in oxygen, as long as there's enough oxygen, anything with carbon burns in oxygen to produce carbon dioxide. Hydrogen burns to produce water. And now we have an add-on, sulfur. So sulfur burns to form sulfur dioxide. Okay, so now we balance the equation, same thing. Who is the element? Oxygen is the element, so we balance this last. Okay, we count the carbon. So you look carefully, there's 2 carbons, 1, 2. So 2 carbon dioxide. And then how many hydrogens are there? 3, 4, 5, 6. So we put here 3. And then we calculate the sulfur. There's only 1 sulfur. So 1. So it's balanced. Okay, now we calculate the oxygen. Okay, so how do we calculate the oxygen? We start from the back. 2 carbon dioxide, 2 times 2 is 4. 3 oxygen, so 3. Here there is 2. So 4, 5, 6, 7, 8, 9. 9. Okay, so what you do here is you put 9 over 2. So this equation is balanced. But as I told you, we always take the whole equation times 2. So 1 times 2 times 2. 9 over 2 times 2 is 9. Two times 2 is 4. 2 times 3 is 6. 1 times 2 is 2. Okay, so do you all understand? You all understand? Kenna? Ziyu, any questions? Do you understand?
Yes.
Okay, you still sound half asleep. Okay, so Okay. Gahe, are you okay? Gahe, you understand now?
Yeah.
Okay, so I'm going to clear this. Okay, we're not going to do everything. So we've done question 1, 2, 3. We're not going to do everything. That's too much really. Okay, so I'm just going to do 2 more. All right. Let's do this for lithium with water. So lithium is a bit special. Lithium is a group 1 metal. It reacts with water to produce lithium hydroxide and water. Okay, and finally, one more is this one, calcium hydroxide and hydrochloric acid. So this is question 9. Calcium hydroxide and hydrochloric acid. Now, don't worry, what it produces, we will learn later on. Okay, it produces calcium chloride and water. Okay, so I only want you to do these 2 questions, 4 and 9. Okay, just do 4 and 9, send it to me, and then we will go on to the next part of this chapter, okay? Lithium plus water become lithium hydroxide and hydrogen, not water. This one is hydrogen. Okay, so we balance the equation. Okay, I'm so sorry, I missed it out just now. Okay, so 1 lithium, 1 lithium, 1 oxygen here, 1 oxygen here, 2 hydrogen here, but 3 hydrogen here. So we put half a hydrogen, right? Okay, so all you need to do is the whole thing times 2. So you get 2, 2, 2, and then half times 2 is just 1. Okay, do you all understand this one?
Yeah.
Can I? Okay, next one. Calcium hydroxide, Ca, remember hydroxide is OH negative 1, calcium is 2 positive, so it's CHOH2. Hydrochloric acid becomes calcium chloride and water. Okay, this one is water. All right, so 1 calcium, 2 chlorine, you put 2 here. Okay, now we count the hydrogen, 2 hydrogen, 4 hydrogen. So you put 2 here, and then what? 2 oxygen, 2 oxygen. Okay, so did you all get it correct? Yes, no?
For
Sort
9
of? For 9 years. Okay, so I think hydrogen, this one is my fault lah. I didn't put the hydrogen here. Okay, now this is what you must understand. We have done so many questions, okay? We have really done so many questions. You have to go back and look back at your questions and revise, and you have to go and look at, I even posted videos and everything. Please go back and look and make sure you remember how to do, okay? Because you cannot, today you remember, then next week you forget, then it's pointless. Okay, so I really need you all to always remember what you have learned. All right, always do a revision the week before. Okay, everyone understand? Okay, can I? All right, so I am going to go to another part now. This one we discussed already, right? Have we discussed this? Yes, right. Okay. All right, so I'm going to go to another part now. Okay, a nuclear number actually tells us how so-called heavy an atom is, but not just how heavy it is, but how heavy it is as compared to another atom. So for example, you look at this, carbon is 12. Remember the mass, or it's called the relative mass, this big number down here, the nuclear number, is also known as the relative mass. That means it's a measurement of mass. It's a measurement of mass, relative of mass, as compared to everything else. So look at this, carbon is 12. And then if you look here, magnesium is 24. Can you see here? Magnesium is 24. Okay. Now what this means is magnesium is twice the mass of carbon. The mass of one atom of magnesium is twice the mass of one carbon of atom. Okay, and if you look at something else, for example, helium. Helium is 4. So carbon is 12, helium is 4. It means that helium is 3 times smaller than carbon. Okay, so we use carbon as our standard because carbon is the most abundant element in the world. Okay, so everything, all these numbers are actually the relative mass. That means the comparative mass of all these elements as compared to carbon. Okay.
Okay.
All right. So now, we talked about compounds. So for example, it's not just carbon we are talking about now. Okay, we also have carbon dioxide. So in the terms of carbon dioxide, how heavy is the whole molecule of carbon dioxide as compared to carbon? So what happens is carbon is 12. Okay, so there's carbon is 12 plus oxygen. So we look for oxygen. Oxygen is 16, so plus 16. But you have to look carefully. There is 2 oxygen. So you must understand this is 2 oxygen. So 16 times 2. So 12 plus 16 times 2 is 44. So if 12, carbon 12 is called the relative atomic mass, then this molecular, this is called the relative molecular mass. Okay, now why is it called the relative molecular mass? Because it's a molecule. Okay, but what you must understand is that it's okay. It's just, if you just say relative mass, also people understand. So what is the relative mass of carbon? 12. What is the relative mass of carbon dioxide? 44. Then what is the relative mass of hydrogen? So one hydrogen is H2. So one hydrogen is 1. So 2 hydrogen is 2 lah. So because it is a relative mass, there is no unit. There is no unit to it. Okay? Can you understand? Can? Okay, now. Understand the concept?
Yeah.
Okay. All right, so how come, okay, look at your periodic table just now. Look at the periodic table just now and tell me which of this, okay, can you see my periodic table? Can? Do you see my periodic table?
Yeah.
Yeah.
Okay, all right. Can you tell me which of these it is not one element but a mixture? But sorry, the element doesn't have a whole number. Look carefully.
Chlorine.
Chlorine. Chlorine is 35.5. Okay. Okay, so how come it's randomly 35.5? Because this number is supposed to be proton plus neutron. How come got randomly 35.5? There's no such thing as half a neutron. So this is where isotopes come in. I've taught you about isotopes, right? So we have isotopes of chlorine, which are 35. We also have isotopes of chlorine that is 37. So if we only say chlorine is 35, it's wrong. And if we only say chlorine is 37, it's also wrong. So what we do is we take the amount of chlorine and amount of chlorine 37 and amount of 35, and then we do a calculation of the average. Okay, of average, how much is the mass, and then we get 35.5. Okay, now I know 35 plus 37 divided by 2 is not 35.5. Yes, but it's not 50%, 50%. So they go by percentage. Okay, and then you might be thinking, hey teacher, that time you taught us carbon got isotopes. What? Carbon got carbon 12, got carbon 13, also got carbon 14. Do you remember when I taught you isotopes? There's carbon 12, carbon 13, and also carbon 14. How come the carbon is only 12? Because 99.99% of all carbon is 12. So after you add all three together, divide, is actually 12.0000 something. So we do not put 12.000 something in our periodic table. We just put it as 12. Okay. So certain things, it's still a round number because the amount of the other the isotopes are so little. All right. So if you look at this one, so for example here, okay, this is what I was talking about. Okay. Finding the AR. Okay, what is this AR? AR is the symbol for relative atomic mass. Okay, AR is the symbol for relative atomic mass. So 75% is 35, 25% is 37. So we calculate the average, you get 35.5. Okay, can you understand this part? Yes, huh? Okay, so now let's look at this. So this is a relative mass of a few elements, okay? So whether when we are doing a ionic compound, we call it relative formula mass, but it's not important lah. Whether it's relative formula mass, relative molecular mass, the calculation method is all the same, okay? So what I want you to do is, here there is a list. You also have your periodic table list, okay? I want you to calculate the relative mass of these elements, okay? So I put for question 4, just do question 4. Okay, can you all see question 4? All right, I only want you to do question 4. Okay, I give you a clue. If you find it very difficult to look at your periodic table, oxygen is 16, chlorine is 35.5, nitrogen is 14, sulfur is 32, hydrogen is 1, carbon is 12, iodine, I think it's 127. Can someone check on that for me? I'm not quite sure. Can't remember. And yeah, that's all. Okay. Let me check and see. Iodine, yeah, iodine is 127. Okay. So this is a very simple exercise. Can you just quickly calculate this and then send it to me? Question 4. All right. So this is basically just math. All right. So CH4, carbon is 12. Hydrogen is 1 times 4. So you get 16. You understand now?
Yeah.
Okay, so in that case, how much is chlorine? How do I calculate for chlorine?
35.5 multiplied by 1.
By 2, there's 2 chlorine here.
Oh, okay. I see.
Okay, so you get 71. Okay, all right. Okay, Matthew, E, how do I calculate E for butane? C4H10, how do I calculate? Matthew? Hey, guys, how can you not be sure? I already told you carbon is 12. Here got 4 carbons, so you just take 12 times 4. And then hydrogen is 1. Hydrogen is 1 times 10. So you just use your calculator, press the number 10 plus, this is butane, right? Okay, 10 plus 48, you get 58. That's all. It's just math. Do you understand?
Yes.
Yes, okay. You guys, I cannot teach you unless you want to learn. Okay, we cannot be staring into the screen and then dreaming about whatever you're dreaming about. Okay, I need you to be present. If not, we are wasting time. Okay, ethanol, C2H5OH. So there's 2 carbons. So carbon is 12, 12 times 2. Hydrogen is 1. There's 6 hydrogen. So it's 1 times 6. And then oxygen is 16. So you just press calculator, add everything together, and then you get 46. Okay? Now, final one, ammonia. Ammonium sulfate. Okay, ammonium sulfate is a little bit tricky because there's a lot of elements here. Okay? So ammonium sulfate, NH4 bracket 2SO4. Okay, so what you need to know is how many nitrogen do you have? Okay, Ziyu, how many nitrogen do you have in this formula? Ziyu, how many nitrogen do we have in this formula?
2.
2. So nitrogen is 14, so you take 14 times 2. Okay, Matthew, how many hydrogen do we have? How many hydrogen do we have? Matthew?
4.
Sorry, what?
4.
No, okay. So you said you have to see the bracket. So the bracket here is 2. All right. So that's why nitrogen, we take nitrogen times 2. So 14, nitrogen is 14. So 14 times 2. So now hydrogen is 4 times 2. So how many hydrogen do we have? Matthew?
Yeah.
Okay, so you have 4 times 2, so we have 8 hydrogen. So each hydrogen is 1, so 1 times 8. Okay, and then we have sulfur. Sulfur is 32. And then oxygen is 16, and then you have 4 oxygen times 4. So you just have to add all of this together. Okay, and then we have 132. Okay, can you understand? So find the relative mass. Find the relative mass of zinc nitrate and find the relative mass of sulfur trioxide. Okay, so zinc nitrate, so we look at this. Okay, this one sulfur trioxide, we write down here first. Okay, sulfur trioxide. Okay, now zinc nitrate, first of all, you must know there's 1 zinc, but 2 nitrogen and 3 oxygen. 3 times 2, 6 oxygen. Can you see that or not? That's the first thing you must understand. There's 1 zinc, but there is 2 nitrogen, and oxygen there is actually 6. 3 times 2 is 6. Okay, if you get that correct, then only you will understand the rest. So zinc is 65. So we take 65 plus, not multiply, plus. Everything here is plus. Then nitrogen, you have 2. So 1 nitrogen is 14. 2 nitrogen is 14 times 2. Okay. Then oxygen is 16. And then oxygen, how many do you have? 3 times 2, 6. Okay, you add them together. You add zinc plus nitrogen plus sulfur. So you're adding them together, plus, plus. Okay, can you understand? So Gahe, you know why you counted wrongly just now?
Yeah.
Okay.
I thought the bracket was multiplied.
Yeah, okay, so 14 times 2 plus 16 times 6. So you get 189. Okay. All right, now this one, sulfur trioxide. So sulfur is here. Sulfur is, oh, where's my sulfur? Goodness. Oh, not here, out there. Sulfur 32. So 32. Plus oxygen. Oxygen again is 16, but there is 3 oxygen. So 16 times 3. Okay, so 32 plus 16 times 3, you get 80. Okay, so I think you guys got this. Now, 189 and 80. Okay, so this is your answer. All right. Okay, do you all understand? Can?
Yeah.
Can I?